Hello all, I am Venkata Malladi. I am here with a presentation on automated extraction of non-functional requirements. What are non-functional requirements? Non-functional requirements specify the quality attributes of a software system. Functional requirements of a software system determine what a product should be, whereas non-functional requirements specifies quality or standards to build a critical system. It answers the question how a product should be. For example, if an organization is developing an app, the functional requirements are like what should the home screen present to a user, what information otherwise, and what features the application presents to a user. But when coming to the non-functional requirements, they are like how easily user navigates among different screens and how secure is the payment procedure. These are like the non-functional requirements. So these are some of the attributes of non-functional requirements. The examples of non-functional requirements. Performance. It defines how fast a software system should respond to user actions under certain workload conditions. Scalability. It assesses the highest workload under which system will still meet performance requirements. Reliability. This specifies how likely the system would run without a failure for a given period of time under predefined conditions. Usability. It addresses a simple question. How hard is it to use the product? How efficiently users can learn and access the system. Portability. It defines how a system can be launched in one environment and working good even in other environments as well. Availability. It describes how likely system is accessible for a user at given point of time. Maintainability. It defines the time required for a solution or its components needs to be fixed, managed or updated. Security. This assures that all data inside the system will be protected against malware and unauthorized access. Why the non-functional requirements are so important? Because they are essential and they define performance boundaries of a system. They help build efficient system and offer key design specifications. Organizations get user experience as feedback and they are so important in determining further features or improvements of the current system. Also, they follow legal and compliance rules. Nowadays, every organization is trying to give its best in technical aspects. But to make a difference, it is in a highly competitive environment. Organizations are focusing on their quality attributes, which are the non-functional requirements. What is our goal? Government and industry-based standards contain critical non-functional requirements for projects. In this era of open source projects, proper documentation is lacking, and developers themselves are inserting new requirements. So, what should we do? What is our goal? To help the business analysts. How? In effectively extracting non functional requirements using machine learning techniques on unconstrained natural language documents through automated natural language processing. To meet this goal, we developed a tool based approach which we call NFR locator, non functional requirements locator, to classify and extract sentences in existing natural language texts and fitting into their appropriate non functional requirements categories. The classification is necessary to determine what role a sentence has, what to be analyzed. Here we are looking for that specific information related to these 14 categories. These are the non-functional requirements that needs to be analyzed using tool-based approach, which is called non-functional requirement locator, to classify and extract the sentences in natural language texts. Which domain are we considering? Here, health domain is considered for this approach, and the data set from which most of the information extracted is promise data set. Now let's see the role of machine learning algorithms in the approach of our non-functional requirements information extraction. Machine learning works as the fundamental function in handling these problems. There are two categories in machine learning called supervised learning and unsupervised learning. In supervised, we learn how to train classifier with label data, whereas in unsupervised, we look for patterns. in the huge corpus of data. As a part of our work, we utilize KNN, naive Bayes algorithm, sequential minimal optimization using Vika classifier. Here comes the NFR locator. We will utilize this in two steps by parsing natural language text and classifying sentences. When coming to the parsing natural languages, the process begins by entering the text into NFR locator, non-functional requirements locator, and thus sentences get parsed into sentence representation. Now, the sentence representation will be considered as tree, in which a vertex has multiple parents. Vertices related to a word, these vertices are related to nothing but word and words lemma. Lemma is nothing but a root word. For example, uh, drink is the lemma for drink, drank, and drunk. Give is the lemma for give, gave, given. So, and edges corresponds to the relationships. That is, vertices are related to words and words lemma. Edges are corresponding to the relationship. We also have a set of small stop words list, that is, which are determiners such as a, and, the, etc. So when coming to step 2 classification, after parsing, we will classify the sentence representation using KNN classifier. That is K nearest neighbor classifier. In addition to KNN, we used a naive Bayes and sequential minimal optimization using Vika classifiers. Why we use Vika? For the sentence representation, we convert all the strings to word vectors. This is possible through Vika filter. And we will be considering the distance metric attribute, which is very important. That is for measuring precision, for measuring recall, and F1 in comparing all the classifiers, because we use different classifiers for sentence representation and classifying and extracting non-functional requirement information from them. In order to evaluate our approach, we will have to give a good reason for each of the following research questions. Answering them would lead us towards the solution. The first research question: what document types contain non-functional requirements in each of the 14 different categories? So, to perform this, we collected 11 documents related to EHR health category. Here you can see these are related to health category. DUA, it represents the data usage agreements. CFR is the United States of Code of Federal Regulations. RFP is the request for proposals. And as you know, requirements, use case, installation manuals, user manuals. All evaluated documents contain almost many non-functional requirements. They contain high frequencies of legal and privacy non-functional requirements. Also, access control non-functional requirements also appeared in almost all documents. To evaluate the research question 2, which is what characteristics such as the keywords or entities do sentences assigned to each non-functional requirement category have in common? To evaluate it, we performed two tasks. First, we extracted the top 20 keywords for each category based upon their ability to predict whether a sentence belongs to a specific category. These are the words accumulated from each category in corresponding documents. For example, choose IHCP, visit, privileges, administration, roles. So these are all related to access control, whereas cookies, encryptions, strong vulnerabilities, usernames, activities, sessions, these are all related to security. Now coming to research question 3, it asks what machine learning classification algorithm has the best performance to identify non-functional requirements. Here in our approach, we used KNN, K nearest neighbor, SMO, naive Bayes, 50% random and random weighted classifiers in Vika filter. So we then performed N cross validation technique where we test the sentences to get classified by each algorithm and produce the precision, recall, and F1 values. Both KNN and SMO did not do so well, but when compared to the initial work, the precision levels are better for the future work. So for that, we can use the SMO classifier as the primary classifier. Coming to research question 4, it asks that what sentence characteristics affect classifier performance. Here the sentence characteristics are also called as the features. So classifiers use any number of features to make decisions. From the classification perspective, we need to make use of information from features rather than the other parts of sentence representation. So the main concentration will be on the features. Here, the original is like the original word as it is in the sentence. Lemma is as discussed, it is the root word. Porter is a stem of the word produced by the Porter stemming algorithm. Casimir represents the pre-processing steps. Pre-processing steps are a part of writing classifiers where we extract some information from a learning algorithm, machine learning algorithm. This determiners A, and are the stop words. Frakes set contains 400 words and Glasgow contains 319 words. By just removing by just removing this determiners, that is these stop words, if we remove them, the F1 measure increased by 27%. Longer stop words have almost no effect on SMO, which is one of the major findings in this research. So what are the limitations there? As our NFR locator works well with only sentences, and it cannot process and extract the informations from tables and images. Within the process, even it is losing the structure of the document contained within Word and Adobe files. To mitigate this, we must parse the document files in their native format. The other limitation is that how our process works well for other system and other domains. Here we considered the health domain, and in future we have also to consider the other domains. So how to extend the future work? There are two ways. One is by expanding the data set within and outside the sector. By this, we can see the classifiers trained in this health domain, how they would work for the corpuses of other domains. The other way is that to use the information extraction techniques from classified non-functional requirement sentences. And also, as we apply more algorithms, the process can learn and apply more patterns. That would give us more insights. Conclusion. In this paper, we derived a process called NFR locator in effectively extracting relevant non-functional requirements from different documents and showed that non-functional requirements existed in many documents. We evaluated multiple classifiers in specific categories and found that the sequential minimal optimization algorithm is impactful for serving the purpose. This is the end. Thanks for listening.